Since I was a kid, I remember watching movies like Star Wars and thinking to myself, how cool would it be to be in a universe like that, where extraterrestrials fight each other with high-tech weapons. My dad always told me, though, truth is stranger than fiction. You don't have to go into sci-fi in order to find crazy creatures with complex weapons. There's a battle going on around the world right now, and I'm talking about the world of bacteria. Since I've come to Notre Dame, I've learned about dozens of different types of bacteria, and they have some of the coolest weapon systems you'll find in nature. We're talking things like hidden blades, blasters, poisons, hive minds. These bacteria are so good at killing that some of them can cause disease. An example of this is mycobacteria, specifically Mycobacterium tuberculosis, which kills over 1.5 million people every year. What is it that makes mycobacteria such a potent pathogen? They have something called the ESX1 secretion system, which is a bioblaster they have tacked onto their membrane. And this blaster fires a set of protein bullets called substrates, which are able to ward off the immune system, allowing tuberculosis to survive and eventually kill the host. Like all of the weapons I've mentioned before, the ESX1 system is composed of a set of little pieces, little individually yet interconnected pieces that have to be put together in a very specific way, just like a Lego set. In order to maintain that specificity, tuberculosis uses a set of DNA blueprints, a set of interconnected instruction manuals, where each page corresponds to a piece of the weapon system. But there's something really interesting about this DNA blueprint. It seems to be able to sense whether or not the weapon system has been made. And this way they can either increase or decrease the amount of pieces that are built at any given time, making sure they have just the right amount of pieces also at any given time. This means that this allows the DNA blueprints to help the tuberculosis make their weapon system with that specificity and that precision. But it also means that reading the DNA blueprints and protecting the DNA blueprints is paramount. And this is where my research comes in. In times of war, nations would often use espionage to sabotage the enemy and gain the upper hand in battle. And we can use a similar type of tactic when it comes to battling disease. I study the DNA blueprints that are required to get the mycobacterial weapon system online. How is it that it's able to sense the presence and absence of the weapon system? How do they relate to each other? In this way, with this type of knowledge, I can stop the weapon system from ever being made simply by manipulating the necessary blueprints, whether it's by taking out a page or manipulating a single line of code or giving them too much of an incorrect page. I can throw off that precision and that specificity that's required in order to get the weapon system online. So to conclude, I'm using micro-espionage to sabotage a complex weapon system that's being used by a teeny tiny creature that's absolutely bent on destroying mankind. Truth is indeed stranger than fiction. Thank you, guys.
Kevin. You know what I'm going to ask you about?
I have no idea.
Your band.
Oh, yes.
Kevin's in a band. In the biology department, I learned. Mm-hmm. What kind of music do the biologists play, Kevin?
Oh, we play so many different types of music. Shout out to Lauren Green in the front there. She's also in the band, so get stoked for that. We play, we play a whole bunch of stuff. We actually play a great swath of variety. So we do play classic rock, we play some pop punk, and then, I don't know.
And the name of the band is?
The Control Group.
I would love to know the runners-up for the name of the band. Maybe don't look in the Petri dish. I don't know.
Sure.
Thanks so much for your presentation tonight.